So my name is A.Hauet from EDF in France, and I have to say that I'm very happy to give this presentation to this great workshop. You know, I've been working on image-based method now for maybe 20 years. It's not as much as HYDRO, but it's quite a long time. And yeah, this workshop, I mean, surface velocity workshop, it's the workshop of my dreams. So I'm very happy. So to go back to the presentation, so far, the previous presentation were mostly focused on discharge measurement. And in my presentation, I will mostly focus on how to measure complex flows and only the velocities of complex flows, and especially around dams. Just to introduce, I'm working for EDF, which is Electricity of France. And it's one of the world's largest producer of electricity. You can see that EDF is mostly using nuclear power plant, but also using hydropower. And it's a big company with, yeah, you can see a lot of customers and a lot of employees. If we look at the hydropower part, you have to know that hydropower is the main source of renewable power in France. And at EDF, we have about 640 dams with a lot of high dams. And you can see that it's covered the different kinds of hydropower facilities, from runoff river to the well-known reservoirs, but also to pump storage and tidal power. And hydropower is very important for us because it's flexible and reactive, so it can make the adjustment to the supply-demand balance within the day. So EDF is doing the operation, but also the engineering of the dams. And we need engineering studies for building. For example, when we want to build a new dam, and here is an example with a brand new dam close to my place in Grenoble in France, a dam that is now effective. We also need engineering studies when we want to size, and especially for the sizing of a flood spillway. And the picture that you can see is a dam for which we had to rebuild the spillway because of a re-evaluation of the decameronal flood. We also need engineering studies just to increase the performance of the dam, meaning that to have the best operational management of the dam, and also to manage the drafts. Then we need studies to ensure the safety of the dam, especially during flood. And for example, we need to have studies to try to estimate the erosion of spillways and of the downstream terrain, downstream the spillway. And last but not least, we need to reduce the environmental impact of the dam. And so we need studies for that, especially about the sediment continuity, but also about the fish migration. In this presentation, I will focus mostly on spillways, sediment continuity, and fish migration. And you will see that for all these engineering studies, a key parameter is the flow velocity. You have to know that between EDF and image-based method, it's quite a long history, and EDF has been a pioneer in the development and the use of non-intrusive method for hydrometry, like surface velocity radar, but especially image-based method and LSPIV. Since now more than 10 years, we have made a lot of scientific developments, and with a lot of also publication of papers in scientific journals. But we also developed some operational implementation of LSPIV for gauging, for fixed stations, mostly for flood measurement, but also for some lab application. And you have here some illustration of fixed station and the lab application on the right. Since 2008, EDF with INRAE have been developing the FUDA LSPIV software, and yeah, James have introduced the software. So, and you will have more details of the software in a demo that I will give tomorrow. So LSPIV, we think that it has reached a high degree of maturity at EDF. It's a measurement we trust in. It's a measurement that we can use for engineering problems. So that's exactly what you said, Nick, just before, is that it's not only a researcher tool, it's not only for some scientific purpose, but it's also now for some operational and engineering problems. So the three examples I want to focus on are the erosion, how to use LSPIV for erosion of spillways, for sediment continuity, or for fish migration. So first example is about the spillways and the erosion. You know, when a flood flow runs over spillways, erosion can occur on dam spillway, and then you will erode the spillway, but erosion can also occur downstream the spillway, and you will erode the natural terrain. And unfortunately, a good example of those erosion was the Oroville dam crisis that happened in 2017. So it was in California. It's a very, very large dam, and the first erosion that impacted the spillway. And then the managers decided to use the emergency spillway that you can see on the map. And then the terrain downstream the emergency spillway was eroded, and the dam was in danger. So finally, they decided to go back to the main spillway, and the main spillway was partly destroyed by this flow. So erosion on a spillway is due to the energy of the water, and the energy of the water is a function of the water velocity. But the question is, how can we measure velocity in such fast, non-uniform, and shallow flow? And yeah, an answer can be LSPIV. So we first made a proof of concept on the Oroville Dam example. So we use a TV video that was recorded from an helicopter that you can see on the image. And we just measured some distances on Google Earth for the auto rectification to get the ground control points. And then we go through the LSPIV analysis, meaning stabilization of the video, auto rectification using the distances, and the PAV velocity measurement. And we measured velocities up to 35 meters per second on that spillway. So it was very high velocities. But the Oroville crisis had some consequences in France, meaning that we had some requests from the National Supervisory Authority to evaluate the potential erosion on our dam. So we started making some application of LSPIV to our dams. And you can see here an example to a dam in the French Alps, Plan d'Amont Dam. And we used GRP from blueprints of the dams. And you can see that we can see the water flowing. So if we can see the water flowing over the spillway, then the method will be able to measure it. And we were able to measure velocities using LSPIV, as you can see in this image. And from the velocities, then we can identify the areas that are prone to cavitation, which is a main problem in spillways erosion. And we can also compute the stream power. And if you know the erodibility of the material of the spillway, then using the graph that you have below, you can identify if you can have scouring or not scouring on the spillway. You can see here two other applications of the method for dam spillways. So on the left, you have an application on a waterfall. So it's on a piano K-ware spillway, and here we measure the velocity of the flow to have the energy of the impact of the flow on the structure. And on the right, you can see that the method can be also applied to very old movie. And here's an example with a movie of the 50s. And you can see that we can use it to measure velocities on the waterfall. So if I jump to sediment continuity, you know that sediments are trapped in dams reservoir. And so it has two main consequences. The first one is that we have a loss of the reservoir storage. And so it can reduce the usable life of the reservoir. But it also deprives downstream reaches of sediment. And those sediments are very important for the aquatic habitats and for the channel forms. So we really need a better understanding of the sediment behaviors on the dam reservoir, but also downstream the reservoir. So at EDF, we use a lot of numerical simulation for modeling the behavior of the sediment, especially to understand the behavior of the sediment in the reservoir and downstream the reservoir. You have an example here of a simulation on the Isère River, close to Grenoble, where we have a migration of alternate sandbars downstream dam regulation. And you can see how complex are the flows with a main flow, but also some branches. And the hydraulic model must be calibrated and validated using field measurement of velocity. But of course, as you can see, the flow pattern is so complex that you cannot use a classical hydrometric tool like a flow tracker, a current meter, or it only gives some punctual measurement, or even an ADCP that will give transect, but it will not be enough to understand the big patterns, the flow recirculation and everything. So again, the question is what kind of measurement can we use to calibrate and validate hydraulic modeling? And here again, LSPIV can be a good tool. In that example, on the Isère River, we used drone-based measurement, and we recorded several videos from a drone that cover the area of interest. And you have an example of one video that, and the location of the video is the red rectangle that you have on the map. And then we apply the LSPIV analysis on all the videos, and we managed to map the velocities over the region of interest. And now it's possible to compare the model and the measurement. You can compare it visually to see if the flow patterns are well modeled, but you can also make some quantitative comparison. And for example, here it's a comparison on the transect number 6, where you have the model in red and the LSPIV measurement in black. So here the LSPIV was used to calibrate and to validate. So that's why the consistency is so good. And of course, we have seen that in previous presentation, but drone is really a great tool for recording large region of interest. Very easily with no perspective distortion, because you can make some videos pointing at the nadir. And it's also very safe compared to other methods that you can use to make some videos from high altitude. But yeah, it's maybe safer to use a drone. Here is another example, just downstream a dam, and you can see LSPIV measurement of 2 jets that are going outside of the turbines of the dam. And this LSPIV field was also used to calibrate to the hydraulic model to understand the sediment erosion just downstream the dam. The last point, the last example I wanted to share with you is how LSPIV can be used for the design of fishways. You all know that dams impact a lot fish migration because dams can block or delay upstream fish migration, but also downstream fish migration. And it can unfortunately contribute to the decline of the species. So we need to design efficient fishways. Oh, the pictures are just on the text, so I cannot read it. But we need to design efficient fishways that are able to attract the fish and on which the fish are able to swim. So the first project I want to share with you is on the Beauvoir Dam. So here you can see the dam. We are downstream the dam, and the flow is flowing to the right. And we had a project here to make a fishway. And the project was to put the entrance of the fishway on the band that is illustrated by the red rectangle that you can see here. So we did some drone videos and made an LSPIV analysis, and we got this result in velocity. And you can see that the band is located just close to an area with high velocities. And so the velocities here of the flow was so high that it was the outflow of the fishway would not been attractive for the fish. So it was not a good location. So thanks to the LSPIV, we were able to propose a new location for the fishway entrance with lower velocity that make the fishway more attractive for the fish. LSPIV can also be used to validate the efficiency of the fishway. And the main question here is, are the velocities appropriated for the fish species that we target? For example, here is a micro roughness fishway for eels, and we know that this kind of fish is able to swim if at a velocity at maximum of 1.2 meters per second for the adult eels, but for the juveniles, the velocity should not exceed 0.6 meters per second. So using LSPIV, we are able to measure after the installation of the fishway if the velocity are acceptable for the species that is supposed to swim on it, and so we can make some acceptance or not of the fishway. So to conclude, I would say that LSPIV is a great tool in the field hydrologist toolbox, but it is a complementary tool with all the other tools that you can have. Just on the discussion just before, we discussed about the low flow measurement, and I would say that maybe image-based methods are not the perfect tool for low flows, and image-based method will always be more uncertain than the intrusive method where you can measure inside the flow. But yeah, the non-intrusive method have a lot of advantages, especially they can measure in a lot of hydraulic conditions, like very high velocities, but also very slow velocities. There is no limit in terms of slow or high velocities. You can measure in very shallow or very deep flow, and very unsteady or non-uniform flows, and you can measure very complex flow patterns. Using drone, you can measure, the measurement can cover very large areas, and it's very interesting when you want to have a picture of a reach and not only a section of the river. Now the image-based methods are very robust and effective, and so we can use them for engineering and operational application. And I just show in that presentation that, yeah, it's possible, and it's a nice solution for engineering studies like erosion of spillways, sediment continuity, fish passages, and a lot of other kind of studies. So image-based methods are ready, but now the question is, are you ready for LSPIV? And I'm happy to conclude with that very nice picture.
Very nice, Alice. We probably, I mean, that's the end of the session, so we should.
Yeah. I'm sorry for that.
Yeah, come on, people, unmute yourselves and applaud. I think